Hello, welcome to Outmouse Labs. My name is Penny, and I'm glad you're here. PixelFalls, the game engine that I have been using in a lot of videos lately, is getting pretty close to its early release, early access, which is really exciting. And because of that, I wanted to run through some game creation with y'all, get you thinking about it. Now, as a reminder, PixelFalls is a Lua-based kind of fantasy console of sorts that runs in your browser. It's pretty similar to Teak 80 or Pico 8, but has some really big differences that I really like. So let's get to it. We're going to be using version 0.10 today. And that does have some new features, so let's start with those. First of all, we have a new home screen. The home screen has access to your game projects that you have saved in the cloud. And there are different types of cloud storage accounts. So for instance, I'm in the founder account, which gives me 10 megabytes. I can save, import, and export my carts from here. And we are going to be going over a game today called Super Neko Jump. So I've got that loaded. Our game settings screen looks largely the same. I believe last video I did, we already did have the frame rate option, so I've got it set to 60. I've got the map load set to auto, the trim characters set to on. This trim characters is really cool. Tighten character spacing by trimming the empty edges from each character when drawing text. Word spacing is auto-calculated when enabled. This is super great. As you may know, in the Zelda-like adventure game I'm working on, I have been setting up the dialogue box, and I can now get actually 5 lines of dialogue on my 128 by 128 screen, which is amazing. Tags looks the same. For this game, we have the tags of fish, player, and wall. I'm going to be using my Miyazaki 16 at 16 color depth. This is exactly the same as before. You can import new palettes with this plus button, and you can have 4, 16, 32, 64, or 128 colors. But I like the 16 colors. It's what I'm used to making art in, and it allows us to use the auto color check or auto color match when we import our art if we are using art from outside. Next up, speaking of art, this is our sprite editor. It has not changed significantly, and I just have a few frames for our character. I have our coin, an urn, a tree, some clouds, some dirt, some distant trees, and a fish. The editor works exactly like you might expect. You can import sprite sheets here. You have all of your standard drawing tools. If you hover over a color, it's going to tell you which index it is. So for instance, red is color 10. If you click on a sprite, it's going to tell you right here which sprite it is. So the fish is sprite 36. Once I imported my sprites or created them in the editor, and I actually did both, I made the fish in the editor and I imported the others, you can go to your code editor and start setting things up. By default, you're just going to have this main file. Over here in the Explorer, you can create nodes or props. Just as a reminder, nodes are complete classes with their own code, and props are sort of like miniature classes that have a x and y coordinate that you can have collision, but they don't have their own code. Okay, so I created a number of props, or excuse me, a number of nodes for this. So we have our player node, we have a grass node, a ground 2 node, an urn node, a fish node, and a tree node. We're not actually using any props. We'll come back to our player node. It's definitely the most complex. Our grass node is just every frame it's running move background, which just means that it's going to be moving to the left constantly and then checking its location. We'll look at that more later. Ground and ground 2 work exactly the same. You could probably go ahead and make like a sort of entity class and then change the sprite at init, and that would save you a little bit of time. And if this was a larger game, that's exactly what I would do. But for the purposes of illustration, I wanted to have them be each individual so you can see how each node can have its own code. Okay, next up we have our urn. Our urn is, again, the same. Our fish is a little bit more. It has a self.x and a self.y determined, and this is because we actually spawn fish with code during the game. But remember, all props and nodes have an implicit self.x and self.y built in. We do our move obstacle. Notice it's move obstacle, not move background. We'll talk about the difference in a bit. And we say that if it is more than -8, so more than 8 pixels off of the screen to the left, go ahead and destroy yourself. This is just basic memory management. Okay. Our tree is exactly like our various grounds and such, except that, again, it's move obstacle, not move background. We'll take a look at that in a minute. So that is everything set up. For those who maybe are new entirely, you can look at, if you hover over, for instance, your player, you can change the sprite by clicking on here. It's going to bring up all your sprites. You can check out the settings. Your settings include things like your origin, which you can move with a click or with these controls here. You can add tags. Tags, again, are set in the game settings section, and then you can click on them here like an enum. So actually, in the background, they are an enum. And then you can turn on collisions on or off, and you can set your collider box. If you click, you can see what your box looks like. So extremely intuitive, very easy. This is my favorite part about PixelFalls. In a lot of ways, it's very similar to something like Pico 8, but where it shines through so much is these nodes with a visual editor that allows you to set up your collisions. Next up, we're going to move into our level editor, where we placed our openings. In our base layer, which is our tile layer, we just have our clouds. Let's see if I can, there we go. We just have our clouds. Our clouds are static, they do not move, so they are just tiles. In our objects layer, or our node layer, we have our first fish, we have our 2 pots or urns, and our tree. So those are just initial locations. The difference is nodes are objects, are game objects that can move, they can interact, they have their own code, so they are on their own layer. Okay, so we have our art, we have our object setup, we have our initial map and locations for nodes. We're getting pretty good, far into this already. Next up, we need to actually start coding things. So let's move to the code editor. Okay, starting with main. We have our life cycle functions: init, update, and draw. And actually, we're using a 4th one that's optional, draw UI. In init, we create our player using the spawn command. Create a player at x of 16, y of 104. Set our current frame to 0. This is about counting for purposes of scoring. Set our game speed to 1 and our state to playing, meaning that we're currently playing the game. If state equals playing, so if we're in the playing state, then the current frame will go up by 1, and if the current frame divided by 60 has a remainder 0, the score will go up by 1. Else if the state is in the menu state, then we're waiting for the key X to be hit by the player to run the game. Draw is called once per frame after update. We're clear screen to 8. 8, if we go to our sprite editor, is this light blue color. We know because if we hover over, we see 8. Okay, go ahead and get back up to where we were. Okay, clear screen 8. If the state is playing, draw our map, and if our state is menu, draw a text saying press X to play, right in the middle, roughly. Our draw UI is always going to create our HUD. Our heads-up display is the little bar at the top of the screen. All right, now remember earlier there were certain nodes that use move background and some that use move obstacle. This is where they're defined. The move background says if we're playing, have everything move to the left by 1 pixel every frame, and if the object is 16 pixels past the edge of the left edge of the screen, then send them to 144. This gives us a constant scrolling background. Our obstacles work similarly. If we're in the play speed, they're going to go back by that same speed of 1 per frame. If they get to minus 16, they're going to be set somewhere between 129 and 144. The randomness makes it more interesting, because if you always knew the direct pattern of the object, how would it be fun? Finally, we check our type here, and if the type of the object is a tree, then we're going to spawn a fish in that same random area. So 128 so between 129 and 144, with a Y always of 88, which is kind of right in the middle of our jump zone. This means that every time the tree recycles, we get an extra fish, so you can get an extra point. It's a nice way of having like rounds within our game, which are set by the tree. Our HUD code is exactly like the HUD code in my last video for the Zelda style game, if you've watched that already. What we have here is a whole bunch of variables, local variables, so local to the create HUD function, set to various numbers so that we avoid magic numbers, numbers that don't seem to have any documentation for what they do in our code. We create a filled rectangle using draw fill rect at 0, 0. The width of the screen, which is 128. The height is 8, and the HUD color is that sort of greenish color. Next, we're going to draw the text, Super Neko Jump, so our title. We'll draw the fish sprite. We'll draw the X for the times how many fish. And then a text that turns the player score into a string and then puts that. That gives us, if we look here, that gives us this bar right here. Also, you can see if it's in menu state, press X to play. If it's in play state, it's running, right? So there you go. That is what all of those do. Okay. Next up, we are going to create our animation. So this is the same animation code from the previous video. It's called animate. This is a nod to the animate function or library in Love 2D. They work entirely different. It's just sort of honoring that incredible bit of code with the name. And again, it takes an object and an animation, and just like I explained before, it is constantly updating the current frame. If it reaches the end of available frames, it goes back to the beginning. And it changes the frame based on the frame speed set by the object's code. If we go to our player, you can see that we have a sprite, a frame timer, a current frame, a frame speed, and then our animations, which in this case is 1. That 12, if you make it larger, it'll sit longer per frame, so the animation will appear to go slower. If you make it smaller, then the animation will go faster, and that's because of this. Okay. Let's see. And then finally reset just sets our state to menu. And we do put it in a function so that we can have our player run it when they run into something. Speaking of our player, let's go take a look at them. It's our last piece of code. So this has an X and Y, a DY, which is like our acceleration in the Y direction, so up and down. We have gravity, jump power, and score. For the animation, we set up the sprite, frame timer, etc., as I discussed. In update, we check, has it collided with something with the tag wall? Again, tags are set up here, and then applied, for instance, our earn has the tag, oh, why did I go in the fish, sorry. Take 2, there we go, earn has the tag wall. Okay, so if there is a tag wall, the player destroys themselves and runs the reset command. So then we go into the menu state. If the player hits a fish, by tag fish, we add the score and destroy the fish. We're using this using the is type, checking to see is the first object in this table we create by getting the collided entities a fish. If it is, you get a point. Jump is always checking, is always running every frame. And what jump does is if self.y is 104, which is our ground, and you press Z, then you jump. The jump you do is the jump power. If you otherwise, well, in addition, it's always doing self.dy, which is that kind of acceleration in the up-down direction, plus self.gravity. So since it's going plus, remember we're going from the top left corner, so that's going to cause the object to go down at the speed of gravity. Because it's plus equals, it's going to be growing constantly, so gravity will get faster and faster. And then finally, we have our self-y, add the self.dy, which is how you get that nice little parabolic jump that we all love in platformers. If you add the gravity directly to y, it's more like this. It's sort of a, you go up and you go right back down. All right, and then finally, if self.y is larger than 104, then we set it to 104, so you never sink into the ground. Okay, so that is what we're doing when we jump. When we animate, we're running the animate code from our main, and we're saying run the animate code on the player, on the self, and use the run animation. Okay, so that is it. That is all of our code. Took me about 90 minutes to 2 hours to make this, maybe a bit longer. And I have a whole game, a complete game. Pretty soon, I know that we're going to have sound effects, and when those are added to the engine, I'm going to come back and show you how to do them. But for now, about 90 minutes, a few hundred lines of code that's really pretty easy, and using a hopefully intuitive editor. I find it very intuitive. you have a complete endless runner that is pretty fun, it's pretty cute, and I hope you will take a look at this code, that you will take a look at PixelFalls, jump into that early release when it comes available, and join us on the Discord when you can, and we will chat. I'm happy to answer questions. You can also leave comments if you enjoyed this, or this is the kind of content you enjoy. If you want to learn more about game design, especially this sort of game design for things like RPG Maker, Pixel Falls, and Teak 80, go ahead and give that like and subscribe. Thank you so much, and happy game making.